Okay, let's go ahead and begin. I'm having some trouble with the network drive, so I don't have today's announcement slide. I think the key thing on that, though, is that your next homework assignment's due on Monday. Has anybody already taken a look at the bond questions on that assignment? Just one of you? All right, so the rest of you still have some good stuff to look forward to. I'd encourage you to get an early start on that and let me know if you have any questions. Remember that in class last time we did two different things. We did some calculations related to bonds, and then we went through the process of calculating the unrecovered investment balance. And so what we were doing is we were looking at how a loan is paid off. What proportion of a payment goes towards the principal, and what fraction of that payment goes towards the interest. And we'll return back to that same concept for some other applications later in the semester. So it's important that you understand, if you were asked to, how to recreate that same spreadsheet that we did during the in-class exercise last time. Remember that this diagram was just illustrating how the interest accumulates during each period, is paid off by the profits that are earned in a particular activity, and then over the course of some years it goes to break even. All right, so what we're going to talk about today is interest rates and how sometimes the interest rate that you're paying on the money you use to finance a project could make a project feasible or could make a project impossible to break even on. So interest rates matter. Here is a comparison between auto rates at two different institutions. At Huntington Bank, back when I did this lookup, they were saying that a 66th-month loan was an APR, meaning an annual percentage rate, where they're taking into effect the effect of compounding. It's 4.72%. But there was Star Federal Credit Union that had a much lower and more competitive rate. They were only charging 2.75% for that same 66th month period. So if you were going to be buying a new truck and you could earn an additional $900 per month in revenue to if you put that truck into service, the question is, should you do it? And what I'm going to show you in the following spreadsheet is just an illustration that the interest rate would affect whether or not the truck is profitable. Because under one set of circumstances, if the interest rate is low, then you'd have a positive present worth, and if you have a high interest rate, then the present worth may be negative. So here's the illustration. Let's say that we have that high interest rate, and it was a comparison of 4.72% versus 2.75%. And so this is an annual percentage rate, and so I have to find the interest rate per period by dividing that annual rate by 12. And then I know what the initial cost of the truck is, $54,105. So here's the initial cost of the truck, and what I know is that if I put this truck into service, I'm getting some extra revenue. So in other words, we have one big expense up front, and so that's a negative outflow of money, and then we have this revenue in the future. But the issue is that over time, that future revenue isn't worth as much in the present terms. And so we have to find the present value of each of these $900 revenue increments. And if you scroll down, you'll notice that I've got that going through 66 months. And so by month 66, if I'm discounting that $900 from 66 months in the future to the present, I'm doing it where the interest rate is the rate per period. So it's just the 4.72% divided by 12. And so each period, the interest rate is less than 0.4%. But still, over the course of 66 periods, that effect of compounding, or I guess rather it would be discounting because I'm moving the money backwards in time, the discounting effect is pretty significant. Over 66 periods, 900 in the future is really only worth less than 700 in today's terms. And so what you'll see is that the total present worth when I add up the cost and the value of the revenues is that I would be losing money on this deal. I bought the truck, but the future revenues aren't enough to cover the present value of the truck if I have the 4.72%. But let's say, what if I went to that other credit union and I got the lower interest rate? And so instead of 4.72%, that's the, I'm going to put 0.0275. So that's the annual percentage. Dividing it by 12 gives me a new monthly interest rate. And so now these future revenues aren't discounted as heavily. You'll remember that the future revenue in month 66, it was below $700. Now, that revenue isn't discounted as heavily because at the lower interest rate, the way to think of it is the bank is taking less of the $900 per month. So the amount that I get to keep is higher. So the present value of the project is positive. So this is just an initial illustration that a project would be yes, except if you're borrowing money at a lower interest rate. Or the other way of looking at it is if your minimum attractive rate of return is lower, then you're going to be saying yes to a greater number of projects. Because when you have a high MAR, that means you're being very selective, very picky. Fewer of the projects are going to qualify. So in this case, there has to be some break-even point where we said yes if the project was 2.75% interest and no if it was 4.72%. And that's what internal rate of return is. And so the idea of balance is something I've mentioned before. The idea that there's an equilibrium between inflows and outflows. I think the previous slide that I had on the subject showed like a pile of rocks that was balancing. And I introduced the thought that when you have the inflows and the outflows equal, that equilibrium means that the present worth of the expense and the future worth of the revenue when taken to the present is all equaling out. And the interest rate that causes that to happen is the internal rate of return. And so we abbreviate that IRR. Now, the internal rate of return can only be positive. You can only calculate the internal rate of return if you have more revenue than costs. And it's easy to solve using Excel like I just showed you. There's also some graphical solutions to internal rate of return where you can do like a linear regression to solve for it. And here's the decision criteria when you're doing an internal rate of return analysis. Remember, analysis is when you're making decisions, and the decision is that if your internal rate of return for a certain cash flow diagram is greater than or equal to the minimum, then you'd accept the project. But if the internal rate of return for that project is less than the minimum, then you'd reject the project. So that's pretty easy to remember, that you accept the project if it gives you more than the minimum that's acceptable. Any questions so far about the internal rate of return? This word internal is important. I mean, maybe so far rate of return makes sense because you're looking at how much you get back after you make an investment. So rate of return should be self-explanatory. But the word internal means something very specific. Internal rate of return is calculating under an assumption that all of the money you get from a project can be reinvested either in that same project or in another project that yields the same rate of return. So the internal part of it is assuming compounding. So you're assuming that all the revenue that's being generated also is itself earning interest at the same rate that it was originally generated. So it's the rate that's being earned on the unrecovered balance. We talked about unrecovered balance on Monday. What that means, it means that you've made a certain investment and you've gotten some profits back, but maybe you haven't recouped all of your original investment. And when you solve for the internal rate of return, it means that you have a zero at the present between the outflows and the inflows. And so if this was a cash flow diagram that you were given, then the process to solve for the internal rate of return is you're trying to find the interest rate that makes it so that these revenues above the line is equal in value to the costs that are down below the line. So there's going to be some well, it's not magical. There's going to be some interest rate that you can solve for that makes the inflows and the outflows equal to zero, and that's the internal rate of return. So the method is that you take all the expenses and all the revenue to the present, and the formula for that is just saying that what you're looking for is if you have any future amounts, you take them to the present. So here inside of the parentheses, P/F means find the present value of a future amount, and the R here means revenue. So you find the present value of all the revenues, where K is which year you're in, starting at year 0 all the way up through the nth year. And there's going to be some interest rate that brings equilibrium between the revenues and the expenses. And so it's going to make it so the present worth is 0 at that interest rate. And this diagram shows that if you're discounting the future amounts at an interest rate that's less than the internal rate of return, what you'll end up with is a positive present worth. And so in our example in this spreadsheet, it's when we had a small interest rate that this was positive. And so if the interest rate is too high, like if I had the 0.0472, then this present worth will be negative. And so there's some interest rate. I could try a lot of different variations, like 0.03, and I'm getting closer and closer to 0, 0.033, 0.034. I'm awfully close now. I could use goal seek, and I could want that total to be 0 and find the interest rate that brings this total to 0. And so that's what this graphical approach is illustrating, is that there's some interest rate that brings the sum of the present worths of the revenue and the expenses to 0. And if you're too small on your interest rate, then your present worth will be positive. If your guess value for the interest rate is too large, then it will make the sum of the present worths negative, because we generally assume that the revenues come in the future, the costs are at the present, and so if you're discounting those future revenues at a big interest rate, then they're not going to be as worth as much as they otherwise would be. So that's why it's negative, is what you're discounting at a higher interest rate is the profits that you'll be getting. Now here's a warning on when you can apply the internal rate of return. You can use it for initial screening, but you can't use it to compare different alternatives. It will tell you if a certain alternative is acceptable, but if you have several different options, the interesting thing about internal rate of return is you don't know which option is best just by choosing the one with the highest internal rate of return. I'll show you a proof of that in a future class, but the reason why is that internal rate of return doesn't take into account the original investment. And so just as an illustration, it would be better to earn 3% interest on $1 million than 10% interest on $1,000. Like, even though 10% is more than 3%, sometimes the original investment amount is going to have a big effect on your overall profits. And so if you're trying to maximize profits rather than just maximize an interest rate, then the internal rate of return cannot be used to select alternatives, but it can be used for initial screening. And then the other warning is this idea of reinvesting. So certain things you can reinvest your profits, like in a bank account. The bank doesn't force you to withdraw your interest each month. They'll let you keep it in the account, and then the month after that, you'll earn interest not only on your original deposit, but you'll also earn interest on what they gave you before. So that's an example of reinvesting your earnings. But there are some business opportunities that you can't reinvest the profits. For instance, if you were going to start that food truck that we talked about, it takes a big upfront investment of $85,000. Well, at the end of each day, when you've sold a certain number of hot dogs, it's not like you can take the money that you earned from that day and redirect it back into the food truck, because you already bought the food truck and you don't necessarily need to reinvest every dollar that you get from the business. And so internal rate of return, when you calculate that rate of return, it's really limited to being applied for those kinds of investments where you are able to reinvest the earnings back into the original business. Okay, so here's where we're going to start off. We're going to start off with this cash flow diagram that I'd like you to translate into a cash flow table using Excel. And then once you have it as a cash flow table, discount it at two different interest rates. Discount it at 7%. Find out what's the present value at 7. And then find out what's the present value at 8%. And so that's going to be similar to the truck thing that I just showed you. And the internal rate of return is somewhere between those two, because what you'll see is that the present worth at 8% is going to be negative, whereas the present worth at 7% is positive. And you're looking to find out what interest rate will give you a present worth of 0. So do part 1 and 2, and then I'll illustrate the IRR function. You can play around with it if you want to see if you can figure it out, but there's a function I don't think I've shown in class before called IRR that I'll illustrate after you've finished problem 2, which is finding the internal rate of return by goal seek. So if you had to spend $800,000 at time 0, and then again had to spend a little bit more at time 4 in order to purchase these future revenues, and you're expecting a minimum of 7% interest, then what it says is you'll get the 7% and also an additional $26,905. But if your minimum acceptable rate of return is 8%, then this negative present worth tells you you're going to be disappointed because you're not achieving that minimum acceptable rate of return. So if we want to find out exactly what is the internal rate of return, we have to do a goal seek where we're trying to get 0 as the sum by changing the input interest rate. So for that, if we started off with 7%, then it gave us a positive. The 8% was the one that gave us the negative. And so here in the data tab, we can find what if analysis, then goal seek. And our goal is for the sum to be equal to a value of 0 by changing I. So that's just the cell where I've got the interest rate guess. And then it goes through some estimates. It finds convergence, meaning that the sum is equal to 0. And so 7.633%. So that's the interest rate that brings equilibrium, balance between the inflows and the outflows. And so what this means is that, let's say that we're talking about a bank deposit. You deposit $800,000, and then that, well, I guess it really wouldn't be a bank. It's a financial instrument. Maybe you've heard of annuities before. It's a way of paying a lump sum now and then getting a stream of income during retirement. So if you paid a lump sum and then the contract says you get a certain amount of interest over time, then this rate of return for that product would be 7.633% is the rate of return for that product. I also mentioned in part 3 the IRR function, and so that's a pretty easy function to use. What you do for the IRR function is anytime you're entering a function, you do equals to let Excel know that you're beginning an equation, and then IRR, and once you put in the parentheses, it starts to tell you that it needs to see values. And it's just as simple as highlighting the range, close parentheses, and it'll calculate the internal rate of return. And I need to show more decimal points here because right now it's just saying 8%, but what I saw from before, it was 7.633, and more than that depending on how you're rounding off. But by putting in this range of input values, what it knows is it's doing in the background with the IRR function, it knows that the first value it sees is at times 0, and then it knows the second value it sees is in year 1. And so it's taking a look at the numbers, the order that they're in, and then it's going through the process of calculating so that the inflow and the outflows are equal, and it's returning the interest rate that would make that happen. And so everything that we set up manually with finding the present worths, summing the present worths, and then looking for it to be equal to 0, it's doing all of that in the background with the IRR function. And don't do it on the present worth of the amounts, do it on the amounts themselves, because the IRR function takes all of that into account. It takes the amounts to the present, and then it solves for the interest rate that brings equilibrium. So who can summarize why we call this the internal rate of return? What is the assumption about IRR? What is internal about this rate of return?
It's only specific to the cash flow diagram, like it's specific to each case.
Okay, that's one way to put it, yeah. The expectation is that you're going to reinvest the money into the same project. And so the profits are kept internal. And so it means that the money that's going to be earned will compound at the same rate. And so it either has to be reinvested into the same project, or if it's also reinvested into an outside project that has the same interest rate, then that's okay too. But internal rate of return assumes reinvestment at the same interest rate because of compounding. Okay, on the back side of the paper, I've given you a problem that's related to bonds. And so I'm not going to give you too much foreshadowing or hints on that one. I'd like you to go back through your notes, maybe the in-class exercise from Monday's class, and try and refresh your memory what all these variables mean and how to solve for the value of the bond. I'll bring the solution to the first couple of problems back up on the screen if you're still working through that. That's fine. We're not in a rush.
So you want 12% annual, but if it's monthly, you have to put it out for a period, so you get 12 months.
Okay, so we've got this bond problem where what we're trying to do is find out what's the value in today's terms of the two components of the bond's value. And so you get money back. The way you get your money back is, number one, the periodic interest payments, and then a single lump sum some time in the future. So in this case, what are the periodic interest payments that we're receiving? Well, it says it's $50 in monthly interest. So that gives us a clue about the number of periods that there's going to be. If the interest is paid monthly and there's 5 years, then that tells us that n, the number of periods, is 60. So here in this formula, N is 60. Now in the previous example that we did on Monday, you had to calculate the product of R times Z. R was the face rate of the bond, and Z was the face value of the bond. But in this case, I've told you directly that it's $50 is the interest payment. And so R times Z is how much interest gets paid each period, and so that's just 50. So what you're trying to do is you're trying to find out if you've got $50 and 60 of those payments, what's the present value of $50 repeated 60 times. So we could draw a cash flow diagram of what that looks like. It looks like 1, 2, 3, 4, all the way out through 60, and the A is $50. We want to know what is the present equivalent of that $50 payment. So what value of I did you use?
1%.
What is it?
Yeah, 1%.
1%. Now, why did you use 1% for I if it says that the annual yield is 12%?
Because it's monthly.
That's right. Well, it's the interest per period. And in our case, it is monthly periods. And so the interest amount per month is 1%. And so what you got to do is you got to calculate the factor. So down here is the equations. We need to use the P/A equation. So this one, the P/A equation, and we're also going to need to use the P/F equation, which is this one. So you need to calculate the factor for N equals 60 and I equals 0.01. What is the P/F multiplier, and what is the P/A multiplier? I is 0.01, N is 60. So that's what I did. Here. All right, so let me zoom out a bit. You can see that better. Okay, so we've got R times Z is $50. The lump sum payment is $6,000, 60 periods, interest rate per period is 1%. So you'll notice I've calculated both of these factors, the P/F factor, 0.5504, and so on and so forth. The ... just means that I'm not rounding it off. I'm keeping all of the precision in my calculator so that I can be accurate to the nearest penny when I do the calculation. And then the same thing for calculating the P/A factor. So the P/A is for finding the present value of the interest. The P/F is to find the present value of the lump sum. So the value of the bond should be $5,550.45. And the two pieces of that value is the value of the lump sum and the value of the interest. And you can see here that I've calculated those separately just so I can tell you how much value came from each part. So we get about, I don't know, more of the value is in the lump sum than in the interest payments. But that's how much you should pay in order to get a yield of 12%. So regardless of what the bond issuer is paying, remember you can get a different yield by either paying more or less for the bond than the original face value of the bond. Any questions about internal rate of return or this bond example that we've done? Okay, so remember that the homework assignment that you've got on your plate due right now is it's due on Monday. And I'd encourage you to get an early start on those bond questions because they get more complicated than this. I mean, it's not like super hard, but it is kind of like the next logical step in the progression of these bond calculations. And so don't leave that to the last minute and everything will go great. Okay, I'll see you on Friday. Have a good one.